Now we ask the question of how do you know how many clusters you want? Well, it turns out if you need some metric to know how well it's working. And the way we measure how well this clustering did is we take these distances and we square them and sum them. Okay, so here's what that means. And this is actually how the algorithm works. So we measure the distance between the centroid and each object. We square it because it could be negative if depending on your axis orientation. So squaring it makes sure the number is always positive. You sum them up, and basically the shorter these lines are, the better your fit. Now I have a question. If I have 15 objects. If I made 15 clusters, what do you think the error would be? This is called inertia. How much? What would be the distances if I had 15 classes, 15 clusters?
0.
Very good. Why would it be 0? Did you say 0, Faye?
Yeah, I did.
Cool. Why?
Since you have 15 of the cluster points, you basically get 1 point for each cluster.
Beautiful. Does everyone understand that? If we had 15 clusters, every object would get its own cluster. I once ran a contest for kite flying, and there were 5 entries, so I made 5 prizes. The highest blue kite, everyone got a prize. So if you have as many clusters as you have items, then you have a perfect score, but it's kind of silly because you really haven't clustered any if you have the same number. The objects are fixed, so you give me a feature table of a fixed number of objects. We're not changing objects. All we're changing is how many clusters we're going to assign those objects to. So we started this example with boom, 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 3. So we have 15 objects, that stays constant. What we can change is the number of clusters we put them in. So what you'll do is do this plot. You have the same number of objects all the time, but keep on running this program, changing the number of clusters.